So this is a lecture over 4.7, pre-algebra, square roots, and the Pythagorean theorem. And the book really kind of jumps into square roots really quick. And you know, what we'd said before is the reciprocal, or kind of like the opposite of multiplication, is division. The opposite of addition is subtraction. If we have 3 squared, the opposite of that is a square root, or the reciprocal of that. The thing that undoes it is a square root. Just like division undoes multiplication, subtraction undoes addition, square roots undo exponents. So what we're going to do, let's look at a few just real basic ones here, kind of get you started. The square root of a number means what number multiplied by itself gives me 9. So in this case, it's 3. Because 3 times 3 equals 9, which is what's inside the square root sign. So you'll get to, if you don't already have a whole bunch of these memorized, square root of 25 means what number times itself gives me 25. And that's pretty much it. You get things like 169. Square root of 169 is what number multiplied by itself gives me 169, and that's 13. And you will have a button on your calculator that looks like that. And you just put in 169, push that button, and you get 13 for your answer. And like I say, it undoes an exponent. So if I said, what is 13 squared? You're going to go backwards and get the 169. You're going to go and get this. So this with a radical sign or a square root sign gives me this. This squared will give me what I started with. So you can it kind of goes back and forth there. So if you continue right above example 1, it gives us a little blue table which has some common square roots. And square root of 0 is 0. Square root of 1 is 1. Those are two that are a little bit different because, like the square root of 4, what number times itself is going to give me 4? Well, the answer is 2. If we have an example like example 1 where it tells us that 7 square root of 64, that means 7 times the square root of 64. So we find the square root of 64. In this case, what number by it times itself is going to give me 64, and that's 8. We're going to multiply 7 times it, and we're going to get 56. So the 7 times the square root of 64 is 56. If we have the square root of 9 plus the square root of 16, okay, one of the things that's really, really important is you can't put those together. You can't say 9 plus 16 is 25 and be able to say, well, then the square root of 25 is 5. Okay, you can't combine these. Can't combine them at all. The only time you can combine them is if the number underneath is the same. And we will get to those later, and that is not the square root of 18. Okay, so anyway, don't combine those. All you can do is look at them each one individually. That's 3. Square root of 16 is 4. Your answer is 7. So notice it's not 5, it's 7. When we have something like the square root of 25 over the square root of 81, same thing. We cannot take 25 divided by 81 and get an answer. We take the square root of 25, square root of 81, and get 5 over 9 when we're done. Keep going with some of these examples here. And we have 12 square root of 25. That is the same as 12 times, what is the square root of 25? 5. Yes, so we get 60 for our answer. Square root of 100 minus square root of 36 is 10 minus 6 equals 4. Okay, so make sure you keep track of that, remember that. Let's see, a couple things you need to know before we get into example 7. is they give us a number such as the square root of 7. Square root of 7 is a number between 2 and 3. Because I know that a number times itself that gives me 7, there isn't one. I know that 3 times 3 is 9, and I know that 2 times 2 is 4, so I know that the square root of 7 is somewhere between 2 and 3, because 2 times 2 is 4, 3 times 3 is 9, so there's some number I'm looking for that when I multiply it by itself, it's going to give me 7, and I don't know what it is. It's somewhere between 2 and 3. And when you have a decimal, when you have the square root of 7 where the number can't be written exactly as a fraction or as a decimal, it's called an irrational number. Now we can approximate the answer like 2.56347 or something. So if you take your calculator and you put in the square root of 7, it's going to give you some really, really, really long decimal. In fact, the decimal goes on and on and on forever. And just to give you a start, it's 2.6458, and it just keeps going on and on and on into infinity. So that means it's irrational when there's no exact number. So we get into problem number 7, example number 7, and they give us 5 square root of 12. So when you are trying to find out what that is, they're saying give the decimal approximation. So you take your 5, you take your calculator, and you put the square root of 12 in there, and they give you 3.46416, and they say, let's round this to the closest thousandths. So they're going to first of all multiply these two, and we get 17.320508. And in fact, this number here, this square root of 12, goes on forever. I mean, the decimals don't end, but let's just end it at 5 decimal places. Multiply it by 5, and we get this. They want us to round that to the nearest 10 thousandths. The 10 thousandths place there's 10, 100,000 right here. That 5 right there is my 10 thousandths place. So to round it, I need to look at the number next to it and see if it's a number greater than, or 5 or greater. Since it's not, then I leave everything as is up to the 10 thousandths and then make everything else zeros. In fact, I can really even erase those and have 17.3205. That's my approximation. And that's what they're doing with numbers, or example 8 and 9.